My name is Eduardo Hirata Miyasaki. I'm a first-year Ph.D. student at the University of California, Santa Cruz, here at the Sarah Abrahamson lab, the SARALAB. Yeah, so this system, what it does, it takes several 2D images at different depths or different focal planes. So essentially, we're taking information from 25 different planes, and then we capture them simultaneously with each camera, and then we can then combine them all together to get the 3D information out of it. So this system is essentially taking what is available in commercial microscopes, and we take in the different components that are inside the commercial microscope, which is essentially like the objective and the tube lens, and of course like these dichroic mirrors that allow us to filter light. And so we can essentially mount, we made these custom-made sample holders, and we have an excitation beam path over here that essentially allows us to excite the fluorophores inside our biological organism, and that when we excite it with that light, essentially we get another sort of light that we can capture that tells us what we're essentially looking at. We submitted our project to the Focus on Microscopy conference, which this year was held actually in London, and so I gave a talk. I gave the rundown of how we made the system, why is it important, and the future applications of the project. And people seem to be really interested because we're one of the fastest methods for acquiring 3D volumes. Yeah.